Hello, everyone. For this lecture, we'll be going over section 6.2, which is on trigonometric functions with the unit circle approach. So we're going to have 7 objectives in this section. First being we want to find the exact values of the trigonometric functions using a point on the unit circle. 2, find the exact values of the trigonometric functions of quadrantal angles. 3, find the exact values of the trigonometric functions of pi over 4, which is equal to 45 degrees. Number 4, find the exact values of the trigonometric functions of pi over 6, which is 30 degrees, and pi over 3, which is 60 degrees. Number 5, find the exact values of the trigonometric functions for integer multiples of pi over 6, pi over 4, and pi over 3. And number 6, use a calculator to approximate the value of a trigonometric function. Number 7, use a circle of radius r to evaluate the trigonometric functions. All right, so quite a few going through there. Also, a note that I forgot to mention in the last section, the page values are on these objectives. So these page values correspond to pages in your book. So you can always view those as well there. All the images and definitions that I get in these notes also come from the book if you would like to read them in the book as well. So, all right. First, we want to recall that the unit circle is a circle whose radius is 1, so that 1 revolution around is 2 pi units. So we see we have our unit circle here. It has a radius of 1, and when we make 1 full revolution, it's 2 pi radians. It says 2 pi units, but it's radians. Then for any real number t, we can locate the points p, which is in the form of x comma y, that corresponds to t. This idea is used to define the 6 trigonometric functions of t, or sometimes called circular functions, but most often called the 6 trigonometric functions. So this to say that we just mean that for any real number t, so for any value of t, there is going to be a point p that corresponds on the unit circle to that number t. So for our definitions of the trigonometric functions of a real number, we want to let t be a real number and let p equals x comma y be the point on the unit circle that corresponds to t. The sine function associates with the t, the y coordinate of p, and it's denoted by sine of t is equal to y. Then the cosine function associates with t the x coordinate of p and is defined by cosine of t is equal to x. Then if x is not equal to 0, the tangent function associates with t the ratio of the y coordinate to the x coordinate of p and is denoted by tan of t is equal to y divided by x. If y is not equal to 0, the cosecant function is cosine of t is equal to 1 over y. If x is not equal to 0, the secant function is defined as secant of t is equal to 1 over x. And if y is not equal to 0, the cotangent function is defined as cotangent of t is equal to x divided by y. So a quick note, if x is equal to 0, then that means that p, or the point p, is on the y-axis. So similarly, if y is equal to 0, then p is on the x-axis. So this all just means that if we have some point p, which is in the ordered pair notation, x comma y, this means that when we want to find the value of this number on the unit circle, these are the kinds of functions that we want to use. So objective 1, so that was a precursor to our objectives. So objective 1, we want to find the exact values of the trigonometric functions using a point on the unit circle. So if we let p equals xy be the point on the unit circle corresponding to the real number t, then we can let theta be the angle measured in radians in standard position whose ray goes through point p and has an arc length of the absolute value of t. So in our images here, we are going to go in order from left to right. So starting with our leftmost graph, we have our graph here, and we see we have this length starting from this kind of initial point to our terminal point, and we're saying that this length is t, and we're connecting to the point p, which is x comma y. So then in our next graph, so we move on from that graph, And on to our next graph, we see we're going to draw in these initial and terminal sides. So now we have our initial and terminal rays. We've labeled this center value theta, so we've labeled our angle, and we're saying that our arc length is the absolute value of t. Almost forgot that word. So we put some more labels on them. First, we just kind of initialize these points. Now we're drawing our rays through them. We're labeling our theta, and we're saying what our arc length is. So then in our next image, we're pretty much just labeling these things. So S is going to be equal to T units, so whatever units that length is in, and we're saying that T is greater than or equal to 0 because it has to be positive. So we have that value, then we're saying that theta is going to be in radians. So we've kind of begun with this initial idea that we're setting these points up. Now we are adding these rays in, and we're finding this value of theta, which is going to allow us to use our trigonometric functions in order to find that value of t. So we went through these three, and now there's kind of a separation here. So that was like how we got there, and now we just have this other example. So in the example afterwards, now we're saying that theta is still in t radians, but now our terminal side has moved, and now we're seeing that S is equal to the absolute value of t, where t is going to be less than 0 since our angle is going in the clockwise direction instead of the counterclockwise direction. So those are just the main two differences there. So basing it off of is theta going to be negative or positive, then we know how we can kind of rearrange this. But either way, t is always going to be positive. Your value of t is always positive. So, your arc length is always positive, which your arc length is the absolute value of t. T itself can be positive or negative, as we've seen, either in the counterclockwise direction or the clockwise direction, but our arc length is always positive. So, that being said, the point P that corresponds to the real number is also the point P on the terminal side of the angle. Theta is equal to t radians. As a result, we can say that sine of t, which t is the real number, can be equal to sine of theta, where theta is in t radians. So we can now define the trigonometric functions of theta, which is going to be very similar to what we saw before. So if theta is equal to t radians, the 6 trigonometric functions of the angle theta are defined as sine of theta is equal to sine of t, cosine of theta is equal to cosine of t, tangent of theta is equal to tangent of t, cosecant of theta is equal to cosecant of t, secant of theta is equal to secant of t, and cotangent of theta is equal to cotangent of t. So by saying this now, what we saw before, we can now replace everything we see with theta instead of t. So we will now refer to the trigonometric functions as both functions of real numbers and functions of angles collectively. So by saying this, this means that we can now view our trigonometric functions as sine of 30 degrees, cosine of pi over 2, cotangent of 225 degrees, tangent of 3 pi over 4, things like that. So real numbers and angles. So it doesn't matter if we use theta as a measurement of degrees or radians now, since they both refer to the point on the unit circle P. So we can now use our trigonometric functions with degrees or radians. They're both referring to the point on the unit circle P, so it doesn't matter which one we use. So we see that sine of pi over 2 is equal to sine of 90 degrees, which is equal to 1, and cosine of pi over 2 is equal to cosine of 90, which is equal to 0, which corresponds to our point 0, 1. Since we know that sine corresponds to y and cosine corresponds to x. All right, so objective 2, we want to find the exact values of the trigonometric functions of quadrantal angles. So we're going to find the exact values of the 6 trigonometric functions for each angle. So for A, we're looking at theta is equal to 0, which is 0 degrees. B, theta is equal to pi over 2, which is equal to 90 degrees. C, theta is equal to pi, which is equal to 180 degrees. And D, theta is equal to 3 pi over 2, which is equal to 270 degrees. So starting with theta is equal to 0. The point on the unit circle that corresponds to theta equal to 0, which is equal to 0 degrees, is P of 1 comma 0. Then using x equals 1 and y equals 0, we can get the values. So let's zoom out over here. So if sine corresponds to y, this means that sine of 0 or 0 degrees is going to be equal to 0. This corresponds to y. And if cosine corresponds to x, this means that cosine of 0 or 0 degrees is going to give us 1. Because remember, p is of the form of the ordered pair x comma y. So in this case, x is 1 and y is 0. So sine of 0 is 0, cosine of 0 is 1. Then tangent, which is y divided by x. If we have tangent of 0, we know y is 0, x is 1, so that's 0 divided by 1, which is just 0. Then cosecant of 0 or 0 degrees is 1 divided by y. Well, we know that y is 0, so cosecant of 0 is undefined because we can't divide by 0. Then secant of 0 or 0 degrees is equal to 1 over x. We know x is 1, so we get that secant of 0 is 1. Then lastly, cotangent of 0 or 0 degrees is x divided by y, where remember we know that y is equal to 0. 1 divided by 0 is going to be undefined. And then we just have our image to go along with it. So we have our ray at 0 or theta equals 0 or 0 degrees, where we have our point there is going to be 1 comma 0. So that's our first quadrantal angle. Our next quadrantal angle is going to be at theta equals pi over 2 or 90 degrees. So this point is now going to be the point 0, 1. So now x is equal to 0 and y is equal to 1. So sine of pi over 2 or sine of 90, which corresponds to y, is equal to 1. Cosine of pi over 2 is equal to cosine of 90, which is equal to x. So that's going to be 0. Tangent of pi over 2 or tangent of 90 degrees is y divided by x, which that will end up being 1 divided by 0, which we know is undefined. Then cosecant of pi over 2 is equal to cosecant of 90, which is equal to 1 divided by y, so 1 divided by 1 is 1. Secant of pi over 2 or secant of 90 degrees is equal to 1 over x. X is 0, so we're going to be undefined. And lastly, cotangent of pi over 2 is equal to cotangent of 90 degrees, which is equal to x divided by y. So 0 divided by 1 is just 0. And then we have the representation on our unit circle. So we see our initial side lying on our positive x-axis, and our terminal side is lying on the positive y-axis. So that would be our 90-degree angle there. Next, the point on the unit circle that corresponds to theta equal pi is going to be 180 degrees, and the point is going to be at -1, 0. So now we have negative numbers. So we're going to be using x equals -1 and y equals 0 to do it all over again. So sine of pi, or 180 degrees, is going to be 0, since y is 0. Cosine of pi, or 180 degrees, is going to be x, which is -1. Tangent of pi, or 180 degrees, is y divided by x, so 0 divided by 1. Sorry, -1. Ooh, 0 divided by -1. There we go. That's just going to be 0. Cosecant of pi, or 180 degrees, is equal to 1 divided by y, where y is 0, so that'll be undefined. Secant of pi, or 180 degrees, is equal to 1 divided by x, where x is -1, so 1 divided by -1 is -1. And cotangent of pi, or 180 degrees, is equal to x divided by y, where y is going to be 0 and x is -1. So we have -1 divided by 0, which is going to be undefined. So in our representation, we see our initial side is lying on the positive x-axis, but now our terminal side is laying on the negative part of the x-axis. So it just looks like one very long line. So we know that this is a representation of 180 degrees, and we see our point there at -1, 0. All right, our last quadrantal angle we have as theta is equal to 3 pi over 2, which is 270 degrees. So this point lies at 0, -1. So now x is 0 and y is -1. So plugging these into our trigonometric functions, we get sine of 3 pi over 2, or 270 degrees, corresponds to y, which is -1. Cosine of 3 pi over 2, or 270 degrees, is going to be 0, because it corresponds to x. Tangent of 3 pi over 2, or 270 degrees, will be y over x, so that's going to end up being undefined, because it's going to be -1 over 0. Cosecant of 3 pi over 2, or 270 degrees, is equal to 1 over y, which is equal to -1, because we have 1 over -1. Secant of 3 pi over 2, or 270 degrees, is 1 over x, where x is 0, so it's undefined. And lastly, cotangent of 3 pi over 2 is equal to x over y, where x is going to be 0, y is -1. So we end up getting 0. Our unit circle representation we see here, we have our initial side laying on the positive x-axis and our terminal side lying on the negative y-axis. And we see how we represent that theta as 3 pi over 2, or 270 degrees. So, all right, and here is a table as well. So this table covers all the quadrantal angles, all of the different trigonometric functions and their values according to the degrees and radians, both theta values. And we see each number is either going to be 0, 1, -1, or undefined. Those are our main attributes there of our quadrantal angle.